So, ladies and gentlemen, welcome to AMS Weather Band's latest webinar, Summer Weather Safety. The Heat is On, with Melissa Griffin and moderated by Cheryl Nelson. Now, before we begin today, there's a few things I would like to address. Some of the ground rules for our webinar. So first, if you have questions during the webinar, please put them in the Q&A section at the bottom of your screen. You'll find it to the left of the regular chat section. Any questions or comments submitted through the chat option will not be considered. So if you want your question addressed, please use Q&A. Also, kindly keep your camera off, and we will also have some specific time for questions from the audience after the interview. All righty. Well, first, I would like to introduce today's moderator. Thank you, Cheryl Nelson, for joining us today. Cheryl's a founder and owner of Prepare with Cher, LLC. Cheryl Nelson is an award-winning TV host and an AMS certified broadcast meteorologist with 2 decades of national and local television experience. Currently, she is also co-host for the national lifestyle TV show, Main Street Living, on the YurView Network. So, Cheryl, again, thank you very much for being here this evening. The floor is yours.
All right. Thank you so much. I'm so excited to be here. We have a great presentation today, and I know that everybody has a busy schedule. So thank you for taking an hour out of your day to spend some time with us. AMS Weather Band is growing, and we love bringing you these interesting topics and presentations. And we have a good one for you today. We have Melissa Griffin. She is going to be our keynote speaker. And Melissa currently serves as the Assistant State Climatologist at the South Carolina State Climatology Office. She received a degree in meteorology from Florida State University and worked for the Florida Climate Center for 15 years, serving as the Assistant State Climatologist for Florida for 6 years. She has also worked for a private STEM education company, the Kentucky Climate Center, and also the Kentucky Mesonet. Melissa has published peer-reviewed research papers on climate impacts on the southeastern United States, co-authored chapters of the book Florida Weather, and is also involved in various weather-related outreach and education initiatives, including COCORAS, or the Community Collaborative Rain, Hail, and Snow Network. She's a busy lady. We're lucky to have her tonight, and Melissa joins us now to discuss tips, tricks, and tactics for staying safe in the heat this summer. Melissa, welcome. And I know you've already had a crazy day today, haven't you?
I have had the evening. So, I mean, thank you so much for that introduction, Cheryl. I really do appreciate it. We are going to be focusing on heat, but as we go through the webinar, I'm also going to be focusing on a couple of other hazards that we see during the summer. And I've had 3 of these hazards in the last 12 hours here in Columbia, South Carolina. Go ahead and jump in and just kind of give you some of the hazards we're going to talk about today. So we're going to talk about UV index and sun exposure. UV index hit 12 today here in Columbia. We're going to talk about rip currents, severe thunderstorms, so thunderstorms and lightning. I actually just had one that came through the area, put down a lot of lightning. According to a lightning tracker that I have, we had close to 3,800 different lightning events, and that's anything from ground to cloud to pulse lightning and clouds in a 30-minute window around where I'm currently located, along with heavy rain and gusty winds. And then also heat. So we had a heat index of about 107 today here in Columbia. And I think our maximum temperature topped out just shy of 100 degrees here. So these are the 4 summer hazards that I'm going to kind of focus on as we go through the webinar. These are the hazards you may not know a lot about. I mean, we definitely have had other webinars and some of our engagement on droughts and floods, tropical cyclones, wildfires, air quality, and even tornadoes. So I kind of wanted to focus on these because they don't necessarily get the attention that some of the other hazards do. So with that, I'm going to go ahead and I'm going to turn it back over to Cheryl because we're going to have an interactive presentation tonight.
Yes, we are. We don't want to just talk at you. We want you to get involved. And so we love doing polls here. So what we're going to do is do some poll questions. And when you see it pop up on your screen, you just pick the answer. And again, you're not getting graded on this. Just pick what you think the answer is and then hit submit. We'll give you guys just a minute to do this. You guys are.
I love watching. I was gonna say, I know I love watching everybody answer them and watching them come in. I think it's a lot of fun.
Yes. All right. We are at 94% participation here. There we go, 100%. Awesome. So I'm going to end the poll. And these are the results. So the question is, you won't get sunburned on a cloudy day, true or false? And the majority of you got that right, because you can definitely get sunburn on a cloudy day. The answer for that is going to be false. Believe it or not, a high percentage of UV rays emitted by the sun can still penetrate through the clouds. So you might look up there and see a milky white sky and think, I don't need the sunscreen today. You should still put that on. Good job, guys.
Exactly. So, and as Cheryl mentioned, with the UV index and the UV exposure, we have the rays that come in from the sun. So when we look at the UV spectrum, there's actually 3 different UV rays that come in through the atmosphere. Or from the sun, UVA, UVB, and UVC. Now, UVC is the most dangerous, but it's actually absorbed by the ozone layer. It's one of the reasons why we back in the 80s, we were so concerned about the ozone layer and the health of it, because it really does protect those damaging rays. The UVA and UVB rays are the ones that actually reach the Earth's surface. So UV rays are responsible for causing the damage to the deep skin tissue. And believe it or not, 95% of the UV radiation that we receive here on Earth comes from the UVA rays. And so they're going to reach deep down into your deep tissue. So you may not see the response to that right away, but it does cause aging of the skin, long-term skin damage. It destroys the collagen in your skin and can give you wrinkles. Where UVB rays is going to reach just the skin, and that's responsible for the sunburns that you get, the redness. And they do both play a role in causing skin cancers. UV rays can also damage your eyes. Most people don't realize this, but you can get a sunburn in your cornea based on the rays and the UV exposure that you get. So there's a couple of different ways that you can protect yourself. And there's these myths out there that are, no matter what your skin tone is, you can develop sun cancer. You can have a sunburn, so that even the fairest skin to the darkest skin, you can damage it based on these UV rays. And this is the thing I learned at a very young age. And unfortunately, never thought about this. I grew up in the Mid-Atlantic, and I ended up going to college at Florida State University. It's a little bit different sun exposure and sun angle from the Mid-Atlantic to down around in the Florida. And that angle of the sun really can cause a difference in the UV exposure that you get. One of the worst sunburns I ever got was in March in Florida, because I was not used to having to put sunscreen on and be outside. And that had to do with being closer to the equator. So
I'm glad that you said that. Sorry to jump in real quick, because people think, oh gosh, I'm young, it doesn't matter, I'm just going to get a tan, I'm not going to burn. But then it does all that damage, and later in life you'll start to get those sunspots and the pigmentation, and hopefully not skin cancer, and you're going to start to see the wrinkles. So it might not get you, when you're 25, but later in life, everything sneaks up on you.
It will definitely catch up on you. And, the UV index is a forecast that kind of gives an idea of the amount of the skin damaging UV that we're expected to see here. And the UV index is done so at solar noon, so the highest point that the sun is in the sky, and that's going to kind of give you an idea of what your exposure is. So you can see it runs typically from about a 1 to an 11. However, the UV index actually goes up to a 15, and the 15 is going to be in those higher elevations, sometimes under the clear skies when you're closer to the sun, but also when you're closer to the equator in the tropics, you can also see those UV indexes be that high. And the lower, even with the lower UV index scale, you can, and that's when we have, like Cheryl mentioned, those milky skies, the cloudiness that we can have, you can still have UV exposure and receive some damage from those UV rays. So, when you're looking at what kind of damage UV, the exposure can be, first degree burns. I mean, you can get a first degree burn from sun, and that's going to be the redness and the really painful, sunburns. And some people even get second degree burns from the sun. And that is going to be, you're going to see blistering. And so you really have to protect yourself when it comes to being outside. Like I said, today here in Columbia, we actually had a UV index of about 12 before the thunderstorms hit. And, just even walking outside during my lunch break, I made sure to have on sunscreen to protect my face. Usually want to use something like a SPF 30 or higher. I also would sometimes walk around with a wide brimmed hat on, you know, just to help keep those UV rays off my face. And you know, wear sunglasses. There's also UPF protective clothing that you can wear. So there are a lot of clothing companies out there that are now making things that you can wear that are moisture wicking and also provide you some sun protection. And I think probably one of the biggest things that you can do in being sun smart is, while most of us love to be outside between 10 and 4, that's usually when you're going to have those peak hours for that UV index. And so just remember to take breaks, take in the shade, you know, apply the sunscreen. Again, if you're out swimming, you're doing activities, you know, you definitely want to reapply the sunscreen. I know you know, when I was younger, I would put it on, but then I would forget to put it on again. And I'd go swimming and be like, oh, it's okay. And then, you know, wake up the next morning with a sunburn. So there are ways that you can protect yourself. And it's really important, especially as you travel, you know, if you're located in the, you know, northern tier of the US and you're making plans to come down to the Gulf Coast or, you know, the Atlantic coast, that difference in that sunning angle could cause, you know, problems if you're not very careful with that UV index exposure. So let's see, Cheryl, did we get any questions?
I do not see any questions yet. Hey guys, as we're going along, you can see the Q&A button on the bottom of your screen. If you have any questions, so we would love to answer them. Make sure you guys are paying attention. I know regarding sunscreen, my dermatologist tells me to wear sunscreen every day, even in the winter. Make it in your moisturizer. It's so important to have on your face, even when you go skiing, for example.
Yeah, so skiing and snow do actually reflect the sun. So even in the wintertime, if you're out skiing, you want to make sure you have sunscreen on your face and you're protecting your eyes. Being out on the water, boating, you know, a night out or a day out on the lake right near the beach, you know, those UV rays can be reflected off of the water surface, and it can actually intensify the UV rays too. So you definitely want to be careful when you're out there. And
Absolutely.
I think I
see a question.
Awesome.
Oh, we have 2 questions. I love it. All right. The first one comes from Suzanne Peak. She says, what do the numbers in the SPF stand for?
So the way that it was described to me is that the numbers kind of give you an idea of, like, if you had like 100 different little beads of sun that were coming at you, and you put on like a 30, it would protect you from about 30% of it. Or if you had a 15, it might protect you from 15% of it. So the higher that it goes, it gives you a better protection of that particular value. You know, you'll see SPF that is as low as 8, and you'll see FPS that is as high as 70. If you're not sure what you should be wearing or what your skin is, you know, where you should be at, most dermatologists will recommend nothing less than a 30. You know, most people like to get a little bit of sun and say, you know, they need the vitamin D. And there are other ways to get vitamin D through food. You know, we do get vitamin D from the sun, but most dermatologists will tell you not to go below a 30. And if you have had any problems with a malignant, you know, a mole or an abnormal mole or anything like that, your dermatologist may actually recommend that you don't go even lower than a 50% or SPF in that sunscreen.
Okay, and we have another question here. Rex Homeland says, what scientific units are the UV rays measured in?
Oh, that is a good question. I don't think I was absolutely prepared for that one.
That is a good question.
I know. I'm like trying to like rack my brain through all of my notes and everything. The UV index, I know it's been, I'm going to have to, you know what, Rex? We're going to hold on that question because I actually want to make sure that I've got that correct for you. And we're going to come back to that one at the end.
Yes.
But those levels were determined through research. And I know that the Climate Prediction Center, NOAA's Climate Prediction Center, has a lot of information on the research and the algorithms that are used to calculate even forecasting UV index. So when we get to the end, I'm going to go back real quick and do a quick little search for my notes on that and see if I can get you the answer on that one.
Awesome. Angie says, are there any tricks or tips to apply in areas often missed?
Oh, that is a really good one. So there are some areas of our skin that we typically will miss, and it's kind of interesting. It's like almost like The scalp is a big one. That's why wide brimmed hats are really important. Or if you don't have a wide brimmed hat, it may look a little ridiculous, but you might want to just run some sunscreen up there, especially in the area where your scalp is exposed. Tops of your ears is another place that's missed. And that's another, wearing those wide brimmed hats really can help. Other places that are missed, believe it or not, the tops of your feet. You wear sandals or flip-flops on a regular, you lotion your legs, you got your arms done, your shoulders, but they miss the tops of your feet. So you want to make sure if you are going to be walking out and you've got flip-flop sandals on, you're at the beach, you are also making sure that those are covered. Backs of your hands sometimes also missed. You think when you apply, it's all on your palms and you don't really think about like the back of your hands too.
All right, and let's do one more. And this is from an anonymous attendee. And he says, you said that the UV index tends to be higher when you are closer to the sun. I've regarded this as a common misconception. The bigger difference comes from the thickness of the atmosphere, doesn't it?
Well, when you think about it, you actually kind of are a little bit closer to the sun when you move to the equator. A lot of it has to do with that angle. So that angle of the sun that you have is like directly overhead. And it really does kind of have that like the amount of atmosphere that you have is, not as much as you would say like up the upper latitudes. It's kind of interesting because even at higher elevations, when you are at closer to the sun, and most of the time, if you think about higher elevations, you're up higher in the atmosphere. So you have less atmosphere that's actually between you and the sun.
All right. Good questions, guys. That was great. I love it. You learn something new every day, and we'll get that other answer for you coming up in just a little bit. But in the meantime, we are going to switch gears and talk about rip currents, which also something very important to know about as we go into the summer vacation season. So I'm going to launch this poll. True or false, rip currents can occur in large lakes. Go ahead and type your answer. You guys are fast.
Yeah, they are. I love watching these results come in. They're so much fun.
Me too. Oh, 100%. Wow. Okay. We're not messing around. So here are the results. And you did very well. The answer is true. Yes, believe it or not, rip currents can occur in large lakes. And we're talking about things like the Great Lakes, obviously big bodies of water. You can certainly get some rip currents there when you have some storm systems or a lot of wind. And unfortunately, back in 2003, on July 4th of all days, 7 people lost their lives due to rip currents on the southwest shore of Lake Michigan. So it's so sad to hear that on the Great Lakes. I mean, we unfortunately hear this all the time on the East Coast and also on the West Coast, but even on the Great Lakes, you have to be aware of that. And Melissa's going to explain more about rip currents and what to do if you're caught in one and how to recognize one as well.
That's right. So, rip currents they're basically like currents, narrow currents of water that flow away from the shore, and they form in a specific way. As the waves come in, they'll go over like sandbars, and as they start to break, they'll kind of create this little circulation that you can kind of see, in that diagram. And as they break, they start to pull away from the shore, and this creates a circulation where you actually have more water that is moving out to sea than is actually coming in, and that rip current can, it will just start to form. I mean, you may not even know that the conditions are out there, and then all of a sudden there's a rip current. And the higher the surf, the more dangerous that these conditions can be. Like Cheryl mentioned with our poll question, they can happen anywhere where waves occur. So on our bigger lakes, like the Great Lakes, Michigan, Huron, Superior, we can have rip currents that exist, that pop up based on different weather conditions that happen. They exist every day, but it really does take the features. So sandbar, the things that we don't necessarily see, the bathymetry that we have underneath of the water, that can lead to an increased number of rip currents that actually occur. Rip currents typically move about 1 to 2 feet per second, which is right around about a half a mile to an hour to about 1.5 miles an hour. But rip currents, the most dangerous rip currents, have actually been observed up to 8 feet per second, which is about 5.5 miles per hour. And that is faster than most Olympic swimmers can swim. So if you just think about a rip current moving at that fast and, that speed, and not even an Olympic swimmer can swim that fast, that should just give you an idea of just how the average swimmer could, once they're caught in it, I mean, you're trying to fight against it. They're not the only current that's out there. There are other currents that swimmers can encounter, and it really depends on where they're swimming at. Some are structural currents. Those can develop along piers. So if you're swimming along a pier, even though there may not be a rip current, there could be a current that develops along that structure. So anything around a pier or a jetty, even a break wall, you could have a current that develops. Longshore currents are those currents that go parallel to the coast. So if you've ever laid out a towel and put your umbrella in the sand to mark your spot, and you've been playing out in the water and you look up and your umbrella and towel are way down the beach, you've actually been caught in one of those longshore currents. Sometimes they move very fast, sometimes not so much. There's other currents, a channel current that and an outlet current, which can form during where streams and rivers actually empty into lakes and oceans. So you can actually find a lot of these outlet currents in the Great Lakes too, as you have some of those streams, rivers, and tributaries that dump into the lake. So there's all these different things that come together, to form a rip current. And, Cheryl mentioned they're not just confined to the beaches. They can be found in lakes. So there are a couple of, ways that you can kind of identify one. When you're standing at the shore, sometimes it's really hard to look and notice where a rip current actually is. But there are some indications if you look at the water. So you're going to look for a channel of churning or choppy water that just doesn't look like the rest of the water in around the area. A noticeable difference in colors too. If you notice that there is a difference in the color in one area of on the shoreline versus another, you could be looking at a rip current. Breaking in the wave pattern. So this image actually kind of shows you a couple of those. You'll notice that there's an area of bluer water. There's a break. You can see that wave doesn't look like it's actually breaking fully. It's got a big gap in it. And there's some foam or some seaweed debris that's actually formed along the lines. So, these are just a couple of the characteristics that you can see from the shore when you're actually looking for a rip current. You should never swim alone or swim at, and try and swim at beaches where there's lifeguards patrolled. If you think there's a rip current, just don't go in the water. Don't go, into the water, and pay attention to any of the signs that are posted. There's a lot of the states now have gone to a beach flag warning system. These are really neat little indicators. They're usually put in at public access points where you can see the color code. Green is a low hazard, but you still want to exercise caution. You're out on the water, anything can change, and conditions can change very rapidly. Yellow would be a medium hazard. Red indicates a high hazard, and usually a double red flag means that the conditions are warranted the closing of the beach. And in some states now, they will actually fine you if you enter the waters when they've actually closed the beach down. And of course, purple in most locations means that there's dangerous marine life, and that can be anything from sharks to jellyfish. Cheryl mentioned, that loss of life that we had on Lake Michigan, a few years ago. So far this year, we've had 26 surf zone fatalities, and 18 of those were from rip currents. And we've just started the summer season. Last year alone, 111 people lost their lives due to rip currents. And that was only behind heat with 190 fatalities and flooding with 146 fatalities. So that was, rip currents unfortunately were the third highest weather-related killer that we had last year. And since 2010, 57 people have lost their lives in rip currents on the Great Lakes. The highest loss of life has actually been along the East Coast, with almost 300 people from Miami to Maine that have lost their lives due to rip currents. And, and unfortunately, it's not just the swimmers. Good Samaritans want to help. And if you see someone caught in the rip, there's options for you besides getting in the water. We had in the Carolinas alone, I believe last year, we had almost 30 people that died from rip currents. And of that, there was a good percentage that were people that were just trying to help. So if you do see someone caught in a rip current, the best thing you can do is get a lifeguard and call 911, and try and get someone who is trained in recognizing rip currents and to be able to escape rip currents to help. You want to give them something that floats. So if you've got a pool noodle, a life jacket, something that floats, you want to try and get it to them so they can hold on to it. Contrary to popular belief, rip currents do not pull people underwater. They just pull them out in the water. So you're not going to have a vertical. It's not going to pull you under the water. What happens is people get exhausted trying to fight the rip current. And that's where, they lose out that energy and have a problem trying to keep themselves with their heads above water. Yell instructions to escape. You can kind of see in this image right here. You want to swim parallel to shore, and if you can't get, necessarily get out, let the current help pull you out a little bit until you feel that current give up. It's not as strong, and then you want to swim parallel to the shore to try to escape. If you can't break free from it, one of the things that you can do is draw attention to yourself. I know trying to tread water and yell and everything is really hard, but in any way, shape, or form that you can draw attention to yourself so if somebody knows that you need help, that's the best thing that you can do. Besides stay out of the water. If you think you see a rip current, the best thing that you can do at that point is try and just stay out of the water. And if you see someone that is caught in a rip current, again, try and throw them something that floats so that they can conserve their energy so that someone can come save them. Don't put yourself at risk too. And unfortunately, too many times that's been the case where a good Samaritan has really tried to help, and we've lost both of the people, and rip currents are one of those things that most people don't necessarily think about, especially on lakes. But when they go to the beach, it's just the waves and the beach, and it's summertime, and they can be very sneaky. I mean, rip currents can occur, and they can, we can have rip current, advisories out. National Weather Service along most coastal areas has what they call a surf forecast or a zone forecast that you can actually look at, and it'll tell you the probability of, whether it's a high rip current hazard day or, a moderate rip current hazard day. But the one thing you have to remember is that, conditions can change. So if you do go out in the morning and there's no advisory for rip currents, you want to watch how conditions change and continue to monitor that weather, because if the winds pick up in a certain direction, it could help the rip currents to develop on shore.
Yeah, and one thing that's interesting to note too is sometimes, let's say you have a hurricane, say 1,000 miles off the shores of the eastern seaboard, that even though it's not impacting the land directly, you can get rip currents from that. So it's pretty interesting. You might think it's quiet weather, the sun is out, it's great, but you always have to pay attention to those advisories like Melissa was saying.
Yeah, I think we actually had that happen last year on the East Coast with one of the storms that passed well offshore, and we ended up having significant high hazard rip current days, and it was multiple days in a row just from having that storm offshore.
Absolutely. All right. Do we have any questions about rip currents? And as you guys are thinking about that, I was doing some research, and also Michael Garfield did as well, about the UV index. And he came up with the same thing that I found. Per the EPA, 1 UV unit equals 25 milliwatts per square meter. So there's a lot of scientific jargon that goes into this. I was reading more about it. It's a lot of calculations, a lot of math to come up with that. So I think if we were to dive into that any deeper, it'd probably be a college level course.
That's one of the reasons I said I knew that looking at, the Climate Prediction Center does have a map that they put out on a day-to-day basis that shows what that UV index high is going to be at high noon. And, just looking at the calculations that they had listed, it is definitely a lot that goes into it. There are some of our derived variables that we're going to talk about here shortly. And actually, that's a nice little lead in the thunder right there into one of the next topics we're going to talk about.
Absolutely.
But that,
in the meantime, Oh, sorry, Melissa.
Oh, no,
I was
it's
just
okay.
typing, if you look in the chat box, I was typing in the Twitter handles. So if you don't already follow AMS Weather Band, that's where it is. And then Melissa, you are ML Griffin. FFIN WX1. Oops, there's not two ats there. And then myself, Cheryl Nelson TV. So yeah, we love to be engaged with you guys. Go ahead and get on Twitter and do that. And as I was typing, we had a question about rip currents. So let's answer that real quick. It's from Angie, and she says, are rip currents possible around flooded areas, such as near the Great Lakes where flooding is occurring?
Well, I wouldn't necessarily call them rip currents, but yes, strong waters when you have flooding can have a really strong, just what we typically call is like a stream flow value. And those stream flow values can get extremely high. And unlike a rip current, we're able to measure those values when flooding occurs. And so, some of the higher values, we talk about cubic feet per second, or how much water is actually moving through an area. And the higher that value is, the higher the velocity actually is. So, in flooded areas, I mean, we were talking about this earlier. We were worried we were going to have to postpone this particular webinar because I was dealing with severe weather here in South Carolina, and actually it's starting to pick up again. And we were talking about there's some of the low-lying areas in the downtown Columbia, South Carolina area where we were having some flooding, and in that we were actually seeing some really strong movement of the water in those particular areas. So we don't necessarily call that a rip current, but we do have like increased stream flow, or high velocity water is sometimes what you'll also hear that called in those flooded areas.
Yeah, that's where you get swept off your feet. That's what takes the cars and sweeps them away. Let's do one more quick question, then we'll get on to thunderstorms. Okay. Rex says, you mentioned the role of sandbars and rip currents, but does the shore alignment or shape impact the formation of rip currents?
Yes, it does. Thank you for that. So, I talked about the bathymetry, which is basically the underlying topography that you actually have. So everything from sandbars to small shelves, but the shape of the shoreline can have that impact too. So those longshore currents that I kind of mentioned earlier, when you have wind that's moving along those longshore, those shores, you can develop those currents, and the longer the fetch is over the water, or how long the wind actually blows over the water, it can actually increase some of those currents. So, sometimes in bays and coves, you can have like a little protected area where you may not have them directly in the bay and cove, but as you come out of that area, around like any of the sandbars that help build that bay and cove, you're actually going to see an increase in those particular currents as the water flows out of that area.
Good questions, guys. Okay, that being said, we're moving on to our next portion, and we are talking about thunderstorms and lightning. We're going to start with a poll. True or false? Heat lightning is another form of lightning. True or false?
Like watching the poll bounce
oh,
back
this
and
is so
forth
interesting.
as everybody is I think we're almost there. We almost have 100%.
Okay. Oh my gosh. Wait till you see this, guys. Look at that. We are split 50-50. So this is something very important to talk about. And the answer is actually false. Heat lightning, there's no such thing as heat lightning. It's actually a thunderstorm in the distance. And Melissa's going to dive into that in this part of her presentation. This is something as a kid that I always thought, oh, it's heat lightning. It's so cool. It's so hot. But no, wait till you hear Melissa explain this.
So with heat lightning, what you're actually seeing is the lightning from a distant storm. We all know light can travel farther than sound. Most of the time, thunder cannot be heard past a distance of 10 miles. So, and it can be even shorter if you have a lot of obstacles in the way. And the obstacles could be anything from buildings to trees to, roadways. So when you have a storm that's really far off in the distance, you can see the light, and a lot of it has to also deal with the curvature of the earth. So depending on how tall or how large these storm systems or these cells can get, you could be looking at a storm that's probably 20, 30, even 40 miles away and actually seeing the flashes of it. Now, the reason why you think it's heat lightning is because in order for the storms to get this big, they typically happen during the summer, which of course is one of our warmest time periods. And it does take a really good hot day to get some of these storms cooking to get to the levels that they typically get in what is known as the mature stage of the thunderstorm. So we'll just go ahead and jump in and talk a little bit about thunderstorms. And when you first have a thunderstorm, you go through what's known as the cumulus stage. So that's going to be the first stage or the initial stage of any type of thunderstorm development. And that's when you get the little warm pockets of warm, humid air that start to rise, and they're going to form those cumulus clouds. And so as they continue to rise and form, they're going to go through that second stage, which is known as the mature stage. And this is going to be characterized by heavy rain, gusty winds, lightning, thunder, possibly tornadoes. And there's a lot of strong vertical motion that's going on in these particular storms. And this is also when the thunderstorm is at its the most intense. The tops of these clouds can reach 40,000 feet. So I believe for most aircraft, typical flying cruising altitude is about 35 to 40,000 feet. So just to give you an idea how high some of these clouds can get. Usually the higher the top of the cloud, the more intense that this is actually, that this particular storm could get. You're looking at, more potential for frequent lightning, larger hail, and even heavier rain, depending on how high those particular storms get. So this is also kind of, and we experienced this just about an hour ago here, prior to the storm actually coming through and the thunderstorms building in here, it was 99 degrees. And as the rain, right before the rain came through, we had a downward rush of that cold air. So you can kind of see it in that diagram, and it dropped the temperature from 95 degrees to 78 degrees, which was a huge relief after dealing with some of the record heat we have had here in the Southeast and in the Midwest recently. And those downdrafts are, they kind of give you an idea of, that the storm has hit this particular, mature stage. And as those downdrafts start to overtake what we call the updraft, so you can see all those little red arrows, which indicate warm, moist air going into the storm. When those downdrafts start to kind of overtake all of the warm, moist air that was going into the storm, that's when the thunderstorm will start to dissipate. And so you may see kind of virga, which is, precipitation that's kind of evaporating before it hits the ground, or you may see the top of the anvil of the storm kind of, dissipate and take over more space. Kind of blowout is one of the terms that we use. And so, but what you're seeing during that heat lightning is you're actually looking at lightning from the tallest part of the cloud. And that's one of the reasons why it's so far away and so far removed. That's why you can't hear the thunder. There actually is a couple of different types of lightning. Ball lightning is one form of lightning, and it's a very rare form of lightning. And then another one is sprites. So some of the sprites that you can see in the atmosphere, both of those are very rare. Most of the forms of lightning that we see are their typical ground to cloud pulses, and our pulses within the actual cloud themselves. So I'm just going to kind of put this up here. This kind of gives you an idea of the annual number of thunderstorm days that we typically get. And of course, down here in the Southeast, it's not uncommon for us to have almost, 60 to 90 days of thunderstorms, just because we do have the atmosphere for it. We have the environment with the warm, humid air. Very rarely do you get thunderstorms that happen on the West Coast, but when they do, they're usually really intense and absolutely amazing and grab everyone's attention because they're so rare and so infrequent, in portions of California, Washington, and Oregon. But most of the time, thunderstorms are going to happen when we have clashes of those air masses with our fronts. So we see them in the spring and the fall. And then, of course, during the summer, just with our regular kind of convection or our sea breeze storms or our bubbly pop-up thunderstorms that we see. And with them, I kind of mentioned some of the hazards already. I mean, this graphic from Weather Ready Nation with National Weather Service, over 280 fatalities each year are from thunderstorm related hazards. And that's everything from tornadoes to large hail, severe wind, to flooding, to lightning. I was telling everyone here, I measured almost 3,800 lightning events. So that's ground to cloud and in cloud pulses with that storm that rolled through Columbia here just, about half an hour ago. That's a lot of lightning to be going on in one particular storm. And with that, we also had intense rain rates. We had anywhere from 2 to 3 inches in an hour period fall over, an urban area. So we had flash flood warnings that were out for our area. And in some cases, I was actually just looking, we had some reports of half-inch size hail, quarter size hail in portions of Lexington County here in South Carolina. So, I could spend an entire webinar just on these little hazards, but I think probably the one I want to focus on right now is lightning. We did talk about heat lightning. This little animation really kind of gives a good demonstration of how it happens. So, inside the thunderstorm, we talked about that vertical motion, that violent vertical motion, and you've got rain and you've got ice that are bumping into each other. And as they're doing it, they're actually creating electrical charges in that in the cloud. And you end up with negative charges, typically like kind of settling down at the bottom of the cloud. And that forces positive charges up from the ground. And just like opposites attract, they want to meet one another. And the way they do that is through an electrical charge, which we know as lightning. So if you've ever rubbed your feet on the carpet on a really dry day and reached out and touched someone and shocked them, that is basically a form of an electric charge, very similar to what we get when we have lightning in the atmosphere. Lightning can, I don't think we've ever been able to fully measure the heat that it puts out, but it is, it's hotter than the sun, over 50,000 degrees Fahrenheit. And when you have lightning, that really intense rapid heating that you have actually causes an expansion of air that creates that sound wave that we hear as thunder. So I'm going to give you kind of two little did you knows as we're talking about lightning here. The first is, did you know Florida is known as the lightning capital of the United States? 3 locations in Florida have the highest lightning density in the United States. And that happens to be Tampa, West Palm Beach, and Daytona Beach. So if you're joining us from Florida and you live along the I-4 corridor, that actually is probably that region that gets the most lightning in that particular area. In 2021, Florida had a total of 223 total lightning events per square mile, and that was more than any other state. And if we look at us as the United States as a whole in 2021, we actually had over 94 million lightning events across the entire United States. So we're not the highest. Actually, Brazil has more lightning in a given year than we can record here in the United States, but we actually do come in as one of the top, I believe, 3 countries for lightning strikes. And then the phenomenon that it's probably very interesting, some people talk about it, is the bolt from the blue. Lightning has been known to strike up to 25 miles away from a parent storm. These particular lightning strikes actually arc out of the top of the cloud. They're called positive charge lightning strikes, and they tend to be more intense than even the negative lightning or the lightning that comes out of the bottom of the cloud. When we talk about that bolt out of the blue, we have occurrences every year of someone saying, that there was a distant thunderstorm and lightning struck, and it either struck a tree, it struck a building, or unfortunately, sometimes it's an individual. This is a really interesting graphic that the National Weather Service has put together, so you can kind of see where your lightning actually risk is. Your highest risk is when the thunderstorm is overhead, but most of the time people have already taken shelter. Your exposure to risk is actually highest when a thunderstorm is approaching and also when a thunderstorm is departing. And part of that is because lightning doesn't necessarily come out of the cloud where it's been raining. It can come out of any part of the cloud, at the top of the cloud, the side of the cloud. So it doesn't necessarily need to be raining for lightning to occur. 2/3 of all lightning occurs between noon and 6 p.m. And this also coincides with when most people are outdoors doing activity. So there's also that piece of exposure too. And of course, lightning, the increase in lightning activity we see is going to be during our 3 summer months, again, when most people are outside. So there's a couple of campaigns and a couple of things to remember when you're actually you're outside and you want to practice thunderstorm and lightning safety. First thing, if you see a flash, you take a dash inside. If you see the lightning flash, you are close enough to be struck by lightning. If you hear the thunder, but you don't see the lightning, again, you're close enough to be struck by lightning. And if you hear that thunder, so when thunder roars, goes indoor, and you need to stop all activities. And the recommendation is actually to wait 30 minutes after the last rumble of thunder before you go back outside. This is giving, at least a good, the storm a good distance to move away from you. And I know once things start to quiet down, people like to go back outside, but that's also where you start to get that exposure risk back up again. The thunderstorm may have moved away, but you still are increasing your exposure to go out. I don't want to spend too much time on this because next week is actually Lightning Safety Awareness Week. I know I believe we've got another webinar, and we've got a lightning specialist who's going to be answering some questions and doing some blog posts about this. There's a Twitter handle. So if you're on Twitter, that's going to be the Twitter, the hashtag to follow for more lightning information as it comes out. So with that, we'll see if anybody has any questions about thunderstorms and lightning.
We do, Melissa. We have a good one from Jackie Lair, and she says, what is the criteria for it to be considered a thunderstorm day? Is this something that the local National Weather Service offices keep track of?
Yes, it actually is. So at the Weather Service offices, they will have different codes, which we actually call METAR codes, and that comes in from our airport locations. And it keeps a track of present weather or weather that's currently happening. So if I were to pull up the METAR code for Columbia right now, it would tell me that there are thunderstorms in the vicinity. So anytime that thunder or lightning is observed, that counts as one thunderstorm day. So it may just be a very small event that happens, or it could be a really large scale event, kind of like the one we had tonight. But that would count as one thunderstorm day. They keep track of this and have been keeping track of this since the 1950s. And so, a lot of the data that we see, even in that map, was from 93 to present. They keep updating that and, adjusting as needed. But they do keep that data. And, the National Weather Service has the criteria. So you can have a thunderstorm day, but you can also have a severe thunderstorm. And that severe thunderstorm has criteria with it as well. It's a 58-mile-an-hour wind. I believe hail has to be a dime size hail or higher on that one.
1 inch. 1 inch.
Yeah, 1 inch hail. And then I'm trying to remember if there was any other criteria. I know the 58-mile-an-hour wind.
Yeah, you got it. Yeah.
So, but they do keep track of that information.
Good stuff. And one thing I wanted to add to the graphic for thunderstorm days, something else I saw from weather.gov is that graphic defines a thunderstorm day as 2 lightning flashes within a 10 nautical mile radius. So yes, if you want to break it down even further, that's kind of some interesting stuff there.
Yes, thank you for the question, Jackie. That was a great question.
Yeah. And okay, if there's any other questions, make sure you put them in the Q&A box, not the chat.
I believe we might have one more question coming in. So I believe like I said, we're going to be having some more information on lightning safety next week. So definitely follow to the weather band, the weather band Twitter, the AMS Twitter, and also the weather band forums, because there's a lot of information that could be posted in there as well.
All right. For the sake of time, we are going to keep going here because I know we have until 8 o'clock Eastern. So we want to respect your time, and we are just going to keep on moving along. So tune in next week for the lightning presentation to get more information about that. In the meantime, how about we do one more poll as we talk about heat and heat-related illness. So this poll is, which state listed below has recorded a maximum temperature over 120 degrees Fahrenheit?
This one takes a little bit more thought. It's not just a simple true false. We got about 66%.
Okay, just a few more people. Got 2 people left. All right, I'm going to close out the poll in 5, 4, 3. Oh, all right, there we go. 100% end poll. Okay, so the spread here, look at that. We
It's
have
really
North Dakota
interesting.
and Oregon. Yeah, they're tied. And the answer is actually North Dakota, 121 degrees Fahrenheit on July 6th, 1936. Wow.
Yeah, it's been a while since that record was actually set. It was interesting to actually watch. No one had initially picked Alabama, and I was like sitting there, I was like waiting and see if anybody wanted to pick the southern state. And Cheryl, what was the highest temperature recorded in Alabama?
Yeah, in Alabama, let's see. Gosh, that was 112 in September 1925. And then let's do Arkansas, 118, July 20th, 1934. Oregon, 119, July 29th, in 2021.
Yep, that was just last year that Oregon one happened. I remember that. They all of these values actually go through a process where the climatologist, along with National Weather Service and members of NOAA, they go through a review process when these records are potentially set to make sure that the data is valid, the station was cited properly, and so moving forward that can actually stand. So, the 122 in North Dakota sometimes throws people off because it's like, wow, that's, I would have expected that somewhere in like Texas or, or Alabama because it's further south. So heat and heat related illness, and this is the third hazard I actually experienced today here in South Carolina. It really starts off with just how the atmosphere sets up. So we may have heard the term heat dome, and a heat dome is it's an area of high pressure, and it kind of settles in over an area and it gets stagnant. It just kind of sits there. And what happens is it acts like a lid on an atmosphere. And so it kind of holds the air in place. But at the same time, in a high pressure system, you have descending air. And so as that air comes down, it kind of compresses and warms, and it can quickly help and heat the ground. And that, with the really clear, beautiful skies and sunny days that we have with high pressure systems, that really can also help increase the actual air temperature that we see themselves. So when we have a heat dome, that usually will lead to a heat wave. So when we're talking about a heat wave, we're talking about a period of 2 or more days where you have abnormally high or uncomfortably hot and humid weather. So I actually went and looked at some of the temperatures that we've had in a couple locations over the last 3 days and kind of looked at their average maximum temperatures. So if you look at Milwaukee, Columbus, Indianapolis, and even Chicago, I mean, their typical highs in June this time of year should be in the low, upper 70s to low 80s. And most of those stations were 90, almost 100 degrees the last 2 days. Nashville, Tennessee, where, it's a little warm there at 88 degrees as an average maximum temperature, 77 or 97, 97, 98. So we're definitely looking at what we consider, a heat wave in a good portion of the eastern United States. Here in Columbia on Monday, we hit 103. We only hit 90 on Tuesday, thanks to convective thunderstorms. Yesterday, we hit close to 100, and today, again, we hit almost close to 100. And that is a little bit warmer than what even we would have here in the South during this particular time of year. So when you talk about heat, there's two sayings everybody always says. It's a dry heat, and it's not the heat, and it's the humidity. Humidity is a measure of the water vapor that you have in an atmosphere, and it kind of gives you an idea of the amount of water vapor that the atmosphere can hold. So, and that all depends on the temperature of the air. So humidity is really is expressed as a ratio, and that ratio gives you a percentage of what the atmospheric moisture is relative to the amount that would be present if it was like saturated, so it was raining. But I kind of like to talk about it. It's really the dew point. Dew point is a temperature at which that air has to be cooled to reach kind of saturation. and it's more of an accurate kind of measure of what the moisture content is in the atmosphere, and it really can help describe a type of air mass. You can have really high humidities but have an extremely dry air mass because of the ratio between the dew point and the actual temperature. So, you know, when you get these really hot summer days and you get that moisture content in the atmosphere, especially here on the East Coast, you know, you can run into some pretty extreme heat. But the dew point really depends on what side of the coast you live on. So, you know, one of the reasons the West Coast is less humid than what we see on the eastern side of the Rockies has to do with the currents that are offshore. So all of our ocean currents move in clockwise. So the particular ocean current that we have off of the Pacific Ocean brings cooler water down along the West Coast. And that West Coast that flow with that cool air, even though it is moist, it doesn't necessarily hold as much water, so you don't get really high dew points. Where in the contrast, that Gulf Stream that goes through the Gulf of Mexico, through the Florida Straits and off the East Coast, you know, it brings warm, moist air and warm waters, you know, along the eastern seaboard. And when you have that moisture in the area along with the warm air, that's where you can actually start to see these higher dew points. You know, the winds along the West Coast often blow from west to east, and they can bring that cool air, you know, onshore to also help cool things off. Whereas when you get southerly winds, you know, along the East Coast of the United States, that does bring in some pretty tropical air mass, and those two, you know, that's one of the reasons why we have such a difference in this dry heat versus humid heat. So, you know, if we what someone might consider in one region to be really hot may not be the same in another region. So let's just take a look real quick at like Arizona. So when we talk about Arizona, we're talking more of like that dry heat. So the air has very little vapor, very little moisture content in it. And the reason why that is actually a very different type of heat is because our body's natural process to release heat is to sweat. And when that sweat gets on our skin, it evaporates, and that evaporative process actually helps cool us down. Well, if we look at a place like Florida, where you have both the heat and the humidity, you've got more water content in the atmosphere, and that really limits that evaporative process to happen on your body. So when you sweat, it doesn't get a chance to evaporate. It just kind of hangs on your skin, and you don't get that cooling process, you know, off of the skin to help cool you down. So when you've got people who are from either the West Coast visiting the East Coast, or tourists from the northern tier of the United States coming to the southern tier of the United States, you know, they can be, especially during the summer, they can be really susceptible to these heat-related illnesses because they're not used to these different climates, with one being the really warm temperatures on general, but then also these changes in humidity values and how they come into play with heat-related illness. Now, you know, most people think that the dry heat is the better heat. And, you know, for the most part, it really is. But with a dry heat also comes a chance to dehydrate a lot faster. So you're sweating, it's evaporating a lot quicker. So you're using a lot more of your own water content. So you need to make sure you stay hydrated. Whereas when you're visiting some place that's really hot and humid, there are a couple of indices that we use to help kind of quantify what that feels like temperature could be. And the first one, and we're going to talk about them, is the heat index. And a newer term most people don't know is WetBulb globe temperature. So heat index has been used for years. Most people know that the heat index is a temperature-based or derived temperature or apparent temperature. It's based on temperature and relative humidity, but it's measured in the shade. So this would be like that temperature you would feel if you were actually sitting in a shaded environment. WetBulb globe temperature, it also is measured in the sun, or also measures of temperature and relative humidity. However, it's measured in the sun. And in addition to that, it also takes into account the angle of the sun, the cloud cover, and the wind speed. So they're two different measures of heat stress, but they're not necessarily quite the same. when we look at heat index, this is kind of that feels like temperature, and most places will actually use heat index. If you look at the National Weather Service, they'll talk about heat index. You might even see it on your weather app where it tells you what the feels like temperature is. And most of the time they're using this heat index. And there's a direct relationship between the air temperature and the relative humidity. So meaning if you have an increase in relative humidity and an increase in temperature, you're actually going to see an increase in that heat index. And if you actually see in the table, the heat indices that are meeting or exceeding 103 degrees can lead to very dangerous, heat-related illness, heat-related illness incidences. And if you have prolonged exposure to those or even physical activity, you could really hurt yourself. One of the newer metrics that is getting mentioned a lot now within the weather community is WetBulb globe temperature. And like I said, it's kind of similar. It's a measure of heat stress, but it takes into account that wind, that solar radiation, or that sun exposure and cloud cover. WetBulb globe temperature has actually been used by the military for decades, and it's actually an OSHA standard. And many of the states recently have started to adopt it into a lot of their athletic and regional organizations. And I know that there are a lot of the high school athletic programs here in the Southeast that are now looking at this for guidelines as they start up summer football practice. So it's a little bit different because if you look, WetBulb globe temperature values are a little different. They only go from about less than 80 to over 90 degrees. But there are different effects that they tell you, if you're working out in them, and different precautionary actions that you're going to take. And the National Weather Service is actually going to be using some of the WetBulb globe temperature stuff in experimental locations this summer, South Carolina being one of them, and North Carolina as well, and kind of trying to get some more information about this particular metric out there. So if you're a person who likes to be outdoors, you're out in the sun, you're this works for so many different things. Like I said, high school athletes, people who are outdoors doing, any type of sporting events, fishing, boating, because you've got that solar exposure to you. You're not just sitting in the shade. And so we're seeing a lot more organizations starting to go towards this WetBulb globe temperature. And, I kind of mentioned the heat-related illness. One of the things that the best thing that you can do is make sure that you take breaks if it's really hot outside. You watch the heat index, try and stay inside during those normal heat hours if possible. Stay hydrated, seek shade, make sure you wear loose clothing. Kind of similar to some of the safety information we talked about with the UV index. But what you want to really watch out for in yourself and in other individuals is, are you thirsty? Are you sweating? Have you stopped sweating? Do you feel weak? Do you feel, are you confused? And if you have any of these signs, you could be having heat exhaustion. You could also have heat cramps, or you could be going into heat stroke. And, as we're starting off, we talked about this campaign and talking, about, let's talk about heat. And then we ended up having this massive heat wave actually take place. We have seen increased instances of people who have suffered heat-related illness because of that. So, we've spent the evening, kind of giving you some of these different hazards, UV index, the rip currents, our lightning and our heat. And hopefully you've gotten a little bit more safety information. If you are coming down to the South this summer, you feel a little bit better prepared and may have a little bit more knowledge moving forward. So let's see if we've got any questions about heat that we can answer, Cheryl.
Yeah, we do. Rex says, in the evenings, can the temperature and humidity ever be such so you can almost see the moisture in the air? What comes to mind for me is fog.
Yes, I'll say you can do that. And, you bring up a good, in the evenings, one of the things that is really important is having that recovery period during the evenings. So if we get really hot during the day, being able to have temperatures drop down into the 70s in the evening gives not only utilities a chance to, have a break, but our bodies have a chance to break too. And if we don't get that recovery period or that cool down period in the evenings, and we go back into another day of really extreme temperatures, then we really start looking at increased instances of heat because you're not giving your body a chance to recover. And, something that comes to mind was the 95 heat wave in Chicago. Not only did we have areas where there was where there were some people who didn't have air conditioning in their building because, Chicago doesn't get hot that often. But with the urban heat island effect and the nighttime temperatures not dropping, people weren't getting a chance to actually recover from those extreme temperatures during the day. And unfortunately, in 95 in the Chicago area, there were a lot of people who suffered. We had not only heat-related illnesses, but also heat-related fatalities as well.
Yeah, that's the scary part too. If people think that they don't have anywhere to go and they're stuck in their apartments. And Isabella has a good question. What's the time lag between heat exhaustion and heat stroke? And I think this varies from person to person, especially if you notice some of the signs of heat exhaustion and you ignore them, then that's going to go on to heat stroke. But as far as a time limit, I think it really varies on any comorbidities. So you might have how active you are, just how healthy you are in general. Melissa, would you add anything to that?
It really, in addition to that, is also the health of the person. I mean, a healthy individual, it might be a longer lag. Small children, the elderly, they can be more susceptible very quickly. And so you could go from heat exhaustion to heat stroke very quickly if you're not like monitoring those conditions. Just one of the reasons, when we talk about weather safety, weather preparedness, with any of our hazards, we always focus on those as being some of the vulnerable populations, small children and the elderly. So it really kind of is dependent on the physical condition of the person as well.
All right. It is about 5 after the hour. So I think we are going to come to a close here. But gosh, this has been such a good webinar. Melissa, I want to thank you so much for your time today. That was fantastic. Gideon, Claudia, everybody at AMS, you guys have been great. AMS Weather Band for arranging all of these webinars. It's excellent to get so much information out there to weather enthusiasts and people who love weather and have a passion just like we do. Don't forget to follow everybody on Twitter. Again, AMSWX Band. And I put my Twitter account and Melissa's in the chat as well. The webpage, if you haven't signed up yet to be a member, you can do that, amsweatherband.org. All right. Anybody else want to say anything to wrap it up before we go?
You know what? I just wanted to say this has been fantastic, Melissa and Cheryl. Thank you so much for sharing this information with us and in such a dynamic manner. Very much appreciated. So yes, thank you. And everyone, guests, thank you for attending. I think that's all the time that we have today. So before we go, though, just want you to know that we will make this video available to Weatherband members at amsweatherband.org and at ametsoc.org. If you have further questions or if you want to talk about the webinar, members are always welcome to discuss on the Weatherband Community Forum. So without further ado, thank you very much for joining us today and take care. See you, everybody.
Bye, everyone.
Bye.